Hi guys, so today we're going to take a look at question 5 of the 2016 exam paper 2. Okay, so in an archery competition, the team consisting of John, David and Mike will win first prize if at least two of them hit the bullseye with their last arrows. From past experience, they know that the probability that John, David and Mike will hit the bullseye on their last arrow is 1/5, 1/6, and 1/4 respectively. Complete the table below to show all the ways they could win first prize. Okay, so they win first prize if two of them, if at least two hit bullseye. Okay, well, in the first way, so John and David could hit bullseye and Mike could miss. Which is the first way that they've already filled in for us. Or John and Mike could hit bullseye. John and Mike hit bullseye and David misses. Okay, so in that case we have a tick, X, tick. Or maybe David and Mike. So David and Mike hit bullseye and John misses. So that would be an X, tick, tick. Or all three hit bullseye because it says at least two. And, presumably if they win, if two of them score, then they also win if all of them score. Tick, tick, tick. Okay, and so that's all the ways that they could win the first prize. Now, on to part 2. Hence, or otherwise, let's just go with hence, find the probability that they will win the competition. So they win if they get first prize. So we've outlined all the ways they could win. So the probability of a win would be, well, the probability that they win the first way, so way 1, or it could happen the second way, so the probability of way 2, or the third way of way 3, or the fourth way. So all the ways it could happen times the probability that it happens that way. Okay. So let's just count these up. Well, what's the probability that John and David score but Mike misses? Well, let's just write this up here. So probability John scores, let's start with John, is 1/5. The probability that David scores is 1/6. The probability that Mike scores is 1/4. Okay, so the probability that John and David score and Mike misses would be, so let's just break this down. Probability of way 1 Well, John has to score, so 1/5. And then David has to score, so that's got probability 1/6. And then Mike has to miss, so that's got 1 minus a quarter, or probability 3/4. So if we multiply these together, then we'll get 3 over 120, or 1 over 40. Now looking at, well, what's the probability that it happens with way 2? Well, John has to score. That's what's got probability 1/5. Mike has to miss, so that's got probability 5/6. And David has to miss, and Mike has to score, so that's got probability 1/4. So this equals 5 over 120, or 1 over 24. And now for way 3, John has to miss, so that's got probability 4/5. David has to score, probability 1/6, and Mike has to score, probability 1/4. So that's got probability 4 over 120, or 1 over 30. And then the final way that this can happen is they all score. So that's got probability 1/5 John scores times 1/6 David scores times 1/4 Mike scores, and this equals 1 over 120. And then the sum of that, the probability of the win, is 3 over 120 plus 5 over 120 plus 4 over 120 plus 1 over 120. So 3 plus 5 plus 4 plus 1 over 120, which is 13 over 120. So that's the probability that they win. Now on to part B. Two events A and B are represented in the diagram. The probability of A intersection B is 0.1. The probability that B without A happens, so B happens but A doesn't, is 0.3. And the probability that A happens but B doesn't is X. Write PA in terms of X, and hence or otherwise find the value of X for which A and B are independent. Okay, so there's sort of two questions going on here. So let's just focus on the first. Writing P of A in terms of X. Now, a mistake might be that, well, the whole thing has to equal 1. So, whole thing equals 1. And the probability that B happens but A doesn't is 0 and is 0.3. So the probability of A, well, that's just the remainder, is 0.7. And, I don't even need X. And this would be a mistake to do it like this because, well, it doesn't actually say anywhere that these are the only two options. In this system of events, these aren't the only two options that can happen. There could be, things over here that could happen. Oops, that wasn't supposed to be a pentagon, but you get the point. Or it could be, there could be a square, a rectangle around it. That's not supposed to happen either. But you get my point. Other things can potentially happen here. So this isn't going to work. But what we do know is that the probability of A is just the probability that A happens and B doesn't, plus the probability that A happens and B does. Because, if A happens, then either B happens or it doesn't happen. Those are the only two situations. So probability of A without B and probability of A with B. And so we have an expression for these. Probability of A without B is x, and the probability of A and B is 0.1. So the probability of A is just x plus 0.1. And, you could see that from the diagram very easily. If you just add up the things in A, you'd get x plus 0.1. This is just a little bit of a more formal way of going about it. So let's just highlight that for ourselves. Probability of A equals x plus 0.1. And now we want to find the value of x for which the events A and B are independent. Okay, well, what does it mean for them to be independent? So two events are independent if, so A, B, independent if the probability that both happen is just the product of the probabilities of either happening. So PA times PB. Okay. So for example, if I flip a coin and then throw a dice, what's the chances that I get heads and a 4? Well, it's just the probability that I get heads, a half, times the probability that I get 4, a 6. So it's 1/2 by 1/6 is 1/12. And that makes sense, It makes sense for those two events to have nothing to do with each other. So, well, we know that probability of A intersection B is 0.1, and the probability of A equals x plus 0.1. And so now the only thing left in this equation to find is probability of B. And, we can just see from the diagram that that's just 0.4. Because it's probability of B without A, the same thing as we did here. Probability of B without A plus the probability of B with A. And that just equals 0.4. Okay, so now we would like for probability of A times the probability of B, so x plus 0.1 times 0.4 equals 0.1. Okay, and now we can just solve for x. So if we divide by 0.4, we get x plus 0.1 equals 0.1 over 0.4, which is just a quarter. And then we bring over the 0.1 and we get x equals 1/4 minus 1/10, or 0.25 minus 0.15, 0.25 minus 0.1, which equals 0.15. And so this is just our answer. If x is 0.15, then the product of the probability of A and the probability of B is equal to the probability of A intersection B, which would make them independent.